Natez, Zachary, Ronil. Okay, we're cracking through. That's good. Josephine, Paul. Good to see we're all ready and wide awake after our week's break. Okay, so without further ado, then let's dive in. So today we're literally going to lift the hood off a computer. We spoke last week about what RAM is, what a processor is, etc., etc. We didn't physically touch on it. So we're basically going to deal with what goes where. So we're going to learn to identify the different components in computers. Better camera feed than last week. Yep, I'm glad we're improving those things anyway. We're going to talk about upgrades, installing memories, identifying different computer components, and the ones that we can and cannot put into our particular system that we have. We're going to have a little chat about expansion cards, and we're going to talk about motherboard. So we're going to explain exactly what the motherboard is and what it does for us. So let's have a little look. So what goes where? The first thing we need to understand is that PC architecture is based around a product called a motherboard. Now, motherboards aren't all the same. They come in different shapes and sizes. They have different configurations and they have different capabilities. Now, we're starting kind of in the second one, and there's standard ATX. This is a regular one that you're likely to get inside one of your regular PCs that you purchase. Now, of course, everything in computers, we like making them smaller, so they tend to make things smaller. So the micro ATX, again, was shrunk down. The mini ITX, again, was a bit smaller. Then you work with nanos and picos, and you end up with devices that can be, nice small devices, or you end up with devices that are massive PCs. Okay, the extended ATX was designed to make it bigger, more capable. And the extended one was really probably the first PC environment, that PC motherboard that allowed you to have a second processor on it. So if you want a big processing system, 2 processors, yes, you are talking extended ATX systems. These are printed circuit boards, okay? So they are very literally a circuit board that is printed on, then they attach all the different diodes to it. Okay, so the typical one that we're going to look at is we are going to pick on the ATX because it is probably the founder and the one that everything kind of springs off of, and it contains the majority of the components that we will always want to speak to. So you can see a very attractive ATX board there. That's actually my one. I sacrificed a PC to build this course. Don't you worry, it's never going to work after what I've done to it. So here we go then. So let's have a look. We're going to have a quick quiz. We know we've got people on here that know about motherboards and know about computers. Some of you have probably already built systems. So let's see. I've red ringed a set of components there. Bonus points go for people in the live chat if they can basically tell me what that device or what that section is. Alien's first in there with memory slots. Buddy with RAM, Sebastian RAM slots, Luca RAM. Yeah, okay. So we can all basically agree this is where our RAM memory goes. Not all RAM memory is the same, and we'll dive into that when we talk about the memory sections. So I've got another couple of red rings there. Anyone want to have a guess as to exactly what those ones are? And by the way, if you've never built a computer or opened the lid of a computer, I'm not expecting you to know this. This is a fun bit of a quiz for those people that have basically dived in there. Sebastian says they're PCIEs. PCI and PCIe. Alan's kind of expanded on that initial answer. You could really call these just expansion slots is probably a good way to put these down as, yes, PCIe, PCIeX, and they are general expansion slots. And we'll talk about expansion cards and what we can do with the things and what use they are. See a couple of you typing in there. While you're typing in there, there's also a red ring there. Does anyone want to tell me, or feel free to have a guess? We allow guesses in this. There's no wrong answer. What that particular section is. Oh, Alan's in there. Maximilian's up there. Zachariah, we're all basically putting CPU slot. Well, CPU. That is actually the CPU in there. That's not a dry slot. That actually contains one. And you can see the messy grey piece on the top. That is your sink liquid type thing. That's your, I've forgotten the name of the thing. As a bonus, anyone who can put that in the live chat. Thermal paste. Thank you very much. See, we give quizzes left, right, and center here. Liquid metal. It's a thermal paste, and we'll talk about what thermal paste is and what that does. Okay, so it is your central processing unit. Okay, there's another ring there, another red ring. System battery. Okay, battery maybe CMOS battery. Well done, Alan. It looks like you've built quite a few machines. You know what you're talking about here, which is great. Yes, this is our system battery. I said all PCs basically have batteries in it. It's unbelievable, isn't it? So this basically keeps the date, the time, all those other, we're going to call them CMOS settings initially, BIOS settings, on the system when we pull the power cable out, because it still needs to know the date and time. There's still a little ticky clock inside it that is ticking on. And we'll talk about that one in some depth later. Now, what about these ones here? Alan again in there. I might ask you not to answer the next one, Alan. You seem to be top of the list all the time. That's fine. SATA cables. So in the good old days, we used to have different types of connections that we connected our disk drives to the system. Nowadays, we're beginning to standardize a lot more on what is SATA cables. We used to have IDE cables and other things like that. And we will talk a little bit around that. But the majority of the time in the modern life that we're in, you will be looking at SATA cables. Now, your SATA cable can be used to drive any disk drive that you're basically putting into the system. So there I mentioned things such as floppies, CD drives, disk drives, whether or not they are spinny disks, so the hard disk drives, or whether or not they are solid state drives, so SSDs. They will all tend to be run through that SATA data cable. We will mention that it is a data cable because your disk drives also need power, and we'll talk about the power getting to those as well later. Okay. So one thing that we will get asked, potentially get asked in the CompTIA exam is what's a north bridge and a south bridge? So we felt we'd probably put an explanation here in here. Okay, the north bridge basically handles what is termed as high-speed communication between your CPU and memory and graphics, while the south bridge managed what's known as slower inputs. So they used to divide them basically. So you had the CPU that would sit there, it would talk to the north bridge if it was something really quick that it needed to do, something that was important for speed, such as accessing your RAM or accessing your PCIe communications devices. So those are the expansion boards. So they were all basically put into what was known as the north bridge, really close to the central processing unit, because it was important that those things happened fast. And the south bridge was the one that was kind of then allocated to sort of everything else. So that was essentially the PCI, the USBs, the ISAs, the ID. Look at those acronyms just falling off of my tongue. Really, these are just other devices in your machine. So BIOS and legacy systems. Okay, and these are the systems that we didn't care if we accessed them slightly slower than some of the ones we wanted to give priority to. Now, this is pretty much an old style. Okay, most modern computer architecture, the North Bridge has basically been replaced by a controller hub. Okay, this is a PCH, one integrated into the central processor unit. Okay, so we kind of don't have a North Bridge anymore. We kind of build that in. But I know we have to mention it because CompTIA A+ exam might well have a question that's related to North Bridge and South Bridge. Let's have a quick thumbs up. Does everyone understand that North Bridge and the South Bridge are slightly different and we don't have to worry about them anymore? Thank you. Again, throughout the course, please feel free to smash any questions. If something is slightly unclear, you're a lot better asking these questions at this stage and we can cover things. And I can say it possibly in a different way that might make it clearer for you. Good. Okay, so let's basically pop on to a very important topic. Okay, Alan basically asked, this architecture is still valid or has it changed? It's still valid, okay, in terms of there are people still building motherboards that have a north bridge and a south bridge. It is not very common. Most of the motherboards that you purchase nowadays will simply have it integrated into the platform controller hub, which tends to be integrated into the CPU. When we're buying machines, do we really need to worry about it? Simple answer is no. The old style architecture will have a slightly faster access on its own to PCI and RAM, but the modern architecture will have faster access to the majority of stuff. So it's a case very much that you don't need to worry about it when you're purchasing a machine or looking at it. There will be specs in there that will tell you things about that, but that is really going into the finite detail of a computer, essentially. And we do not need to worry that much about it. As I say, the only reason we mention it is because the exam can basically bring a question up about it. And that answers that one for you, Alan. Thank you. Okay, so RAM, let's have a look at the most common modules. We don't go into absolutely all the RAM modules because there's hundreds. If I went back to when I was young, a young boy, the RAM chips were expanding rapidly and they had different configurations and different types were coming out every other month. So the most common modules that you are likely to deal with are what is known as dual inline memory module. That is a DIMM. Okay, everyone calls them DIMM chips. Okay, these are common for PCs and servers. Okay, you can get slightly different memory for servers than PCs, but in general, they can basically be the same style of memory. And all of that depends on what you are doing with the server and the PC. You will notice on all of these systems, there are little notches cut into the chips. This is for us, really. This is to stop us putting them in the wrong way round, okay? Makes it very nice and intuitive for us. Now, these are common, as I say, within PCs and servers. And then we come to things such as the small outline dual inline memory. Okay, so that's a SODIMM. SODIMMs are basically used for laptops and smaller devices. Okay, and as it says on the tin, they are smaller. Okay, you need more compact. Do they have less memory on them? No, they can contain as much memory, but you can imagine you are trying to pack it into a smaller device. Okay, and therefore it's tougher for them. So those are the two common memories that you will have in your systems nowadays. Now, as I said, not all memory modules are basically the same. So let's have a look at a couple of the key attributes. So key attributes of RAM are the clock rate. So the chip clock rate is used to determine the speed of the module. This is how fast essentially you make the thing vibrate, how fast you basically make things access. Okay, and they will vary in a different amount of speeds, and we'll go into the numbers, etc. in a minute. There is a bandwidth on these things, which reflects the amount of actual data that can be transferred per second. Okay, so not only do you have a clock speed that sets the speed, you also have a bandwidth, which is the maximum amount of data that can get transferred to and from. And then we also have transfers per second. Okay, this accounts for the amount of data operations. This is different from the bandwidth. It's the amount of data operations that can be performed by that chip. And then we have the number of pins for a DIMM and SODIMM, which represents the number of physical pins in that memory module. So when we're buying memory, this is the stuff we're basically interested in, as well as the size of that memory. So a memory chip will normally come with a size, clock rate, bandwidth, transfer, and a number of pins. So let's put that into a bit of an example. This is what I mean by chips basically coming out year after year after year. DDR, as I say, direct memory access chips, originally 1998, had a maximum chip clock rate of 200. Wow, super fast at the time it was. Maximum bus transfer rate, MT per second, 400. Maximum bandwidth, 3200. And you will normally see these written on the chip. So if you're taking an old computer apart a lot of the time, these will be noted on the chips. They don't note the number of pins and they don't expect you to count them, but it used to be 184. The more pins, basically, the more memories we can address. And SODIMMs came with 200. And again, then we kind of went, well, we're going to improve that. 2003, DDR2. Again, we're increasing the amount of the clock speed. We're increasing the MT per second. And we're increasing the maximum bandwidth. And as time went on, we made further and further improvements. Now, I put these figures up there. We don't expect you to remember these figures. CompTIA will not come to you and say, a DDR2, what was the maximum clock rate? Okay, that isn't going to be a question. The important thing that you know is that not all memory is the same. So a DDR2 chip will perform differently from a DDR chip. Okay, currently DDR5s. I'm not sure for DDR6 at the moment. I haven't actually looked recently, to be honest with you. But you can see there the maximum clock rate, 450. Okay, again, that's a massive improvement on the original DDRs, but you'd expect that sort of thing. And we're now running at 57,000, which is the bandwidth. The 57,000 is the important values. These ones tend to be the important, is the maximum bandwidth and the number of pins. Now, when you do kind of get memory and you are kind of a bit strapped or awkward positions and things like that, you can actually put a higher rate memory chip into a lower rate machine. But ideally, you want to match your machine. Your motherboard will tell you what processors, what memory type it is expecting to receive. Manufacturer's website will basically publish this, and it will tell you what memory you need to buy. It will tell you the number of pins, the DDR rating, the maximum bandwidth, and you simply purchase one that matches your motherboard. Okay, you cannot just force any other system into there. You can imagine you can't put a DDR2 into a DDR5 slot because the physical number of pins that you're trying to connect is different. So it simply will not link up. Any questions about DDR and DRAM versions? Okay, well, pretty good then. Okay, I said it isn't just as simple as just getting RAM. Okay, there are different types of internal memory. The standard RAM is RAM, as it says, read random access memory. Okay, this means the information can be modified. You can write to it, you can read from it, you can change it. So the type of storage, it is volatile. Remember we talked about memory the other week, and we said if something is in memory and we turn the power off, pull the power cable out the back, we lose it. That is our volatile memory. That is RAM. Commonly used for CPU processing, so it's very fast, costs a lot of money, and you can basically get some large capacities. So this is our regular RAM chips that we basically have, and this is our DDR stuff. So again, this is our very friendly chips that we basically have. Then the other type is ROM, read-only memory. Now, just as it says, the information cannot be modified on it. It is permanently written to that memory. Okay, benefit of that is that if you lose power to it, it doesn't change. Okay, so this is why it's ROM. So read-only memory, if we pull the power cable out, it doesn't lose any of the details on it. It's normally used for BIOS, okay, and the UEFI, and we go into those in a minute, okay, so don't confuse yourself with that. But the BIOS is basically used as a pre-operating system boot information. So you can imagine if we lose the battery, so if we pop the battery out, we pull the power cable out, our BIOS does not change. We put a new battery in, we plug it in to the power cable, we turn it on, and our BIOS does exactly the same as it did when it was created by our manufacturer. Downside of it, it is slower than RAM. Okay, not a big deal because we're only doing it during the boot sequence. So it basically affects how quickly we boot up. It is quick enough for us not to worry about how slow it is in boot up process. Okay, it is cheaper. and the size is normally very small. Why would we have it big? Okay, we do not need a load of information that's permanently stored on our machines. So that is two different types of internal memory that you'll find on the system. You will not buy a read-only memory in this sort of format. It will be welded onto your motherboard. It will be hard in there, or they have them also in printers. They have them in all sorts of devices that you basically have. Okay, and they are normally welded onto the motherboard. Right, but there are different types of RAM. Okay, so there is what is known as static RAM, which is SRAM, and dynamic RAM, which is DRAM. The differences are very obvious there. So, well, very obvious, that's wrong for me to say that. Static RAM is faster, okay? It costs a lot more. Okay, the power consumption is higher, commonly used for cache memory. So this is the memory that is stored really close to your processor, okay, and is used to access an awful lot of information really quickly. Okay, so that is your static RAM. Tends to be a lot smaller when you basically put it into the machine because it costs a lot more. Commonly used, as I say, for cache memory. We have cache on our processors, we have cache on our disk drives, we have cache all over the chip shops. Okay. Then we have DRAM. So DRAM tends to be slower. It's not slow, don't get that wrong. It's not slow, it's really quick, but it is slower than SRAM. Okay. It is cheaper. Okay, it consumes less power, and this makes it much more popular because we've got something that's cheap, it's using less power consumption, which means we don't have to burn so much electricity, slightly slower, and it's tend to use for our main memory. So this is really the stuff that I keep waving this around. So this is this sort of stuff that we're actually putting in and out of our machine. It's quite cheap, fairly slow in terms of memory performance, but not in terms of what we tend to think of. Any questions about the difference between SRAM and DRAM? I can see Alan typing, that's good. Periodic refreshments is basically about burnouts. Okay, so it might need a little nudge every now and again to refresh what is actually either written on there, or basically you need to replace the things. Right, he asked a question there that basically goes along the lines of, have they used SRAM instead of DRAM for bigger improvements? The difference is, yes, they are faster, okay? So if you really have a system that needs to run really quickly and it is mission critical, yes, you'd put SRAM into it. Okay, you'd pay the bucks, you pay the extra power consumption, smash SRAM into it. So there's no reason you can't use it, and manufacturers do indeed produce these as SRAM chips, but you are paying a lot more money. I can see Ronell typing as well then. Let's see what we've got there. Have you got a question there, Ronell? Normally SRAM is good question. Yes, if it is used for things such as caching, then yes, it will be built in. But there's no reason that you can buy SRAM in this sort of format. Okay, so if you're running a server that's really important, you have some really fast memory access, then you can go and purchase SRAM and pay through the nose for it. So it's not always built onto the motherboard. Good, I'm loving the questions. This is great. You will need a compatible motherboard. Your motherboard must be compatible with the memory that you're putting into it. Okay, but both the motherboard will tell you, your manufacturer will tell you, as well as the chip manufacturing. Okay, and then just to add to things, there is another flavor of memory of RAM out there. So ECC RAM, which is error correction code memory RAM. Okay, technically what it actually does is it detects errors. Okay, every time we write a piece of data to anything such as a disk drive, such as a memory chip, there is the potential that there might be a bit that's wrong. There might be something that is failed, something that is incorrect, a bit of corruption that happens in it. Now, normally what the system does is when the system writes, it checks. So it writes, checks, writes, checks, writes, checks. What ECC does is ECC prevents you from having to do that, and it does it itself. Now, the way it does this is it has a check bit in it. So there's a single bit errors that can basically be picked up by these particular systems. So if you imagine writing a load of numbers, let's give a good example here. So if we write 10010, wow, that's a load of numbers. And then we have a check bit because we can add the number of ones up there and we can go, that's 3. That's an odd number, so we put a 1 at the end. If one of those bits is incorrect and we lose a 1 and it's replaced by a 0, we get 0011. And that means the total for those is 2, which doesn't match with our check bit. So our ECC goes, oh, that piece was written incorrectly, and it corrects it. So it can make those corrections. So that's the idea with single bit correction. One of the drawbacks of ECC is it requires an extra bit on the end. So it requires a little bit of an extra chip. It costs slightly more because you are basically building small redundancy into the system. It will tend to only really get used because modern computers are so reliable and fantastic. It tends to only get used on mission critical systems. Okay, if you are running something, a particular server that must not go down, that needs to be up. For example, if you're looking after aeroplanes in the sky with your servers, you might go, we don't want any faults in this. Potentially, we'll use ECC RAM in all our servers to make sure that we are safe and nothing tends to go wrong. So it basically means they are very, very reliable. Fintan asks there, can ECC memory itself be corrupted? Every piece of memory can be corrupted. ECC is designed to be less corruptible. Okay, the idea is that it should never be able to be corrupted because you are using a check bit to prevent that corruption. It's like belt and braces, really. Anyone got any other questions around that particular types of memory? Good stuff. So this is the example I gave within ECC RAM. Okay, as you see, it's represented by a check bit, which is a 1 or a 0 that basically correlates to the number of items in it. So for example, a 1-byte word contains 8 bits. And that check allows us to basically check that out. As you see, depending on whether or not the parity is odd or even, will tell you whether or not a bit has been corrupted in that system. Good stuff, everyone. Okay. Any further questions around RAM before we start talking about installing things? Good. So let's have a little look at a RAM installation. So first question you ask yourself is, which RAM do I install? Okay, the form factor in terms of the number of pins is important, and you'll find all these details from your motherboard, from your manufacturer's website, or off the good old-fashioned internet. You'll be able to find details about these items. So there's the form factor. Is it DDR5 or is it DDR? which version is it? How many pins does it have? And the number of pins will normally correlate to the notches that are in it. So it will prevent you putting the wrong one into the wrong place. We need to make sure it has the right bus transfer. Yes, make sure it's got the right bus transfer, so you've got that. And the maximum RAM the motherboard can support. Not all motherboards are built the same. Paul's basically asked what bus transfer is again. Bus transfer, remember, was that really large number that talks about the speed and the bus transfer rate. Oh, let me flip back to that slide. Only because it takes just a second. Right, there's your bus transfer speed, so the MT per second. Good? Perfect. And once you've got all those up and ready, then really you're looking to install the system. Now you can see there on there, which round do I install? You can see in there, there is actually a notch cut out. So that notch normally will always correspond to a little divot that is basically put into that RAM slot. I'm hoping that is clear for you. Put your hand up, thumbs up if you can see the notch and the little divot that's basically in the RAM slot. Great stuff. Sometimes it comes out quite clearly, sometimes it isn't. Perfect. So once you've got those aligned, because it will always be at one side of the chip, it will never be in the middle. It will be one side or it'll be two. That means you will always put it in the right way around. On the edge of essentially the cassette there are little clips. Now these little clips are there basically to hold it in place. We know with the PC you get heating, cooling. That tends to make things work slightly loose. So these clips are designed to hold it in place as well, but they are kind of as a bit of a guide. And you know when you've got it in because the clips will close on the system. So as you push the RAM down firmly, but not aggressively, the things will close on the side and you'll hear a reassuring little click normally. Well, that's good for PCs and good for servers because it's the same as servers. But we also do the same for SODIMMs. So you can see SODIMM installations is pretty much the same. You can see there's a notch there as well on the SODIMM. That means you will put the SODIMM in the right direction. And when you push the SODIMM in, you push it all the way in, and then it essentially folds down on top of it. So it folds into place, and you can see there is the little notch that means that you've got it in the right place, and you see that corresponds to the piece that sticks out. And these are your two retention clips. So those two clips will actually flick over as you push it in. And if you need to remove it, you need to push those two retention clips to one side, and the chip will very simply flick up gently towards you. It's not like a Wallace and Gromit toaster. It doesn't fly across the room. It just gently flicks it up towards you as you push those two clips out to one side. Good. Any questions about that installation of memory? Don't be scared of memory. One thing I always say about every single thing we talk about computers is to be firm but not aggressive. Okay. The reason it's not going in, if it doesn't feel like it's going in, the reason it's not going in is because it's in the wrong hole. Okay. Because the slot's the wrong way round, or you're trying to put the wrong size memory into the wrong size place. That is the same across a lot of PC environment. If the cable's not going in easily, it's because it's the wrong cable in the wrong hole. Okay, and I'll repeat that several times. Okay, memory channels. Okay, we all know we built PCs. If we haven't built PCs, we'll tell you anyway. There is a reason that we have essentially the beige, we'll call them white, the white and the black memory channels, memory slots there. Okay, because the technology allows you to talk essentially to channel A and channel B, and I'll talk about channel A and channel B in a second. And the whole idea is to increase the system performance. So it allows your CPU to have more memory modules simultaneously using it without having to basically cross over the items. Now your DIMM slots must be occupied. There's one you must occupy, which is DIMM slot XMM1 socket. It's normally the primary socket, and it's normally comes already filled. But if not, you can look at your motherboard, and somewhere on your motherboard next to one of these, there will be a little label that says XMM1. If that one isn't filled and you filled all the others, well, the system won't talk to anything because it checks that that first one is there. That's the primary one that it uses. So let's have a little look at our example. In this example, we've got a 2-channel processor. I know there's 2 channels on this processor because I've got a black and a white DIMM slots. Channel A will talk to DIMM slot 1 and 3. They're both black. That's perfect, isn't it? They're very easy to work out. Channel A, there you go, 1 and 3. Channel B will use the 2 white ones. Okay, that is slot 2 and 4. Now, has anyone got any questions around this? I know there's an obvious question I'm going to answer. I'm just lining you up for it. I can see a couple of you typing. Let's see what we come up with. If channel A and B still using the newer version of the motherboard. Yes, this is separate. This is separate from it. This is only talking to the memory. So don't get confused about north and south. We are simply communicating with the memory, which essentially will be on the north one. If you ever get asked that, you won't get asked that in a CompTIA question. But your memory is always talked through the north, the quickest method to get to the processor. Is this in parallel? How does it work? Look at that, Alan. Thank you very much for asking that question. I think that's probably the one I was after. Okay, so how probably the other one I was after was how do we know which ones to fill up first? The simple answer is imagine that you're basically talking out 2 separate directions from that processor. So I'm allowed to have 2 conversations. Okay, if I'm having 2 conversations, I'm speaking twice as fast as I normally do, which horrifies most people. But we can talk twice as fast through 2 different channels. Okay, so if I put memory in channel A, I can talk to that memory quick. If I put memory in channel B, I can talk to that memory quick. Great, that's fantastic. But if I've only got 2 chips and I put them both into slot 1 and slot 3, wow, channel A is loaded. They've got loads. But what's channel B going to talk to? Channel B cannot talk to anything. So I lose that form of communication. Yes, I've got lots of memory talking to channel A, but now channel B sat there going, I can't have a conversation. So what you've got to do is you've got to fill them up equally. Okay, so you've got to put something into primary, which is slot 1, which is normally our XMM1 slot, which must be filled. That is our primary channel. And then we put it in slot B. So we go black and white. And that means our processor can use that memory to its most efficient manner. Then if I get another piece of memory, another one, I'll put it into 3. And if I get another one, then I'll put it into 4. Do they have to match? No. I would recommend you match the channel memories. So all channel A should have the same memory and all channel B should have the same memory. When we talk about that, we talk about speed, size, and everything else. So in theory, all channel B and all channel A do not have to match. So I can put different chips in channel B than I put in channel A. So for example, in channel A, I can put 2 512 megs. And in channel B, I can put 1 gig. Okay, I've got 2 channels. They're both talking to 1 gig each. I've got 2 gigs available on that processor. And I've only used 3 essentially of my channels, my slots. Now, when you get your head around that, that's great. Does everyone understand that? Let's have a look. Any questions around how that works? I can see Alan's basically, you had an answer there, Alan, but I'll answer it for everyone else as well. What happens if you put one in slot one and a second in slot two? That's the way you're supposed to do. So you want memory in slot one, then slot two, then slot three, then slot four. So that's the normal order that you'd fill it up. Does that answer that, Alan? Have you had a good answer from both? Good. All clear. Hello, thank you very much, Paul. Well done. Cool, that's great. So as a good example, when we start talking about bigger systems, channels, we have different channels. Okay, I'll use this as an example. A HP ProLiant DL380, don't have to remember it, Gen 10. It's a big server. Okay, it's one of the old HP servers. Okay, it has 4 channels. So we don't have channel A and B, we have channel A, B, C, D. So 4 channels. Okay, which can host 12 DIMM slots per processor. Okay, at 3 DIMMs per channel, dual processor configuration. Yes, you can see you can get loads and loads of memory talking to your processors. So 4 channels you can have in those. In your PC stuff, tends only really to come down to 2 channels. Right, that kind of covers off memory. Any questions around that? Well, I'd quickly slip on to expansion slots. No idea why that image is there. It's a totally irrelevant image to a HP ProLiant. Done for entertainment. So let's have a look at our expansion slots then. So PCI is a type of computer bus. It was created in 1990. God, that's ages ago. Okay, it was used because people wanted to put more and more devices onto a computer, but they didn't want to have to essentially solder them into the motherboard. We wanted to be able to say, well, hold on, I want a couple more network cards. I want a couple more serial or parallel cards basically going in there, parallel communication happening. I wanted to run multiple monitors, but they didn't want to kind of go, well, that's all it's going to do, and I'm going to have to solder it in. So they invented essentially the slots. Oh, look at that. Caliph, I'm going to answer that one. Can mismatched RAM modules still work in dual channels? Yes, they can still work. As I said, I'd recommend you fill slot A with exactly the same all the way through. So channel 1 and channel, well, number 1, number 2, number 3 rather. And channel B, you have the same as all channel B. So match channel B and match channel A, but channel A and B don't have to be the same. Great. Okay, so the most recent revision of PCI was basically PCI Express, so PCIe. Okay, it's the most common found, but why do we have them? We have different ones because we need different speeds, okay? The more you have, the faster you can communicate with it. Okay, they essentially come in 4-lane configuration. So PCIe X1, X4, X8, X16. Right, and the multipliers refer to the number of simultaneous lanes in the architecture. Now, what good are simultaneous lanes in the architecture? It is like me talking again. I'll use the talking example again. If I've got one lane, I'm having one communication. I'm talking to a serial card, network card, let's call it a network card. I'm having one communication if it's a single one, a PCIe X1. If I then kind of go, well, I've got a PCI 4, then again, I'm having more communication, more conversations with that single card. I'm talking faster to it. Loads more data is going around. Same with 8, same with 16. So if you have something that is going to need a lot of data communication to it, you have it in a PCIe 16 slot. What do we throw loads of data to? Our beautiful video systems. So if you buy graphics cards, I think most graphics cards nowadays are PCIe 16s. Yeah, communication is all in parallel. That's the point of having it as that way, because you can talk really quickly at the same time to it, essentially throwing loads of data down it. Good questions, Alan. I'm liking this. Thank you. Here's a quick question. Like in the live chat window, uh, type in anything you think would be suitable in a PCIe slot. Has anyone got any extended cards, expansion cards? What do you think we could use in there? Audio cards. Yeah, modem card. Andy, thank you very much. That's good. Very good. Graphics cards. Yeah, we all love our graphics cards. Power graphics users. Yeah, when we play our gaming machines. Wi-Fi card. Yeah. Yeah, definitely Wi-Fi cards can be it. Network adapters. Yes, multiple adapters. Network cards. Sound cards. Yes, it used to be the good old-fashioned way. You used to have to put a sound card in to a PC before you could get sound out of it. Bluetooth cards. Yeah, very good, Sebastian. Yes. So it is SATA expansions, or Alan. Now you're pulling it out of the bag, now, aren't you? Yes, SATA is a different form of disk drive communication that was used for external disk drives. I mainly used it with tape drives, and we'll talk about tape drives when we do backups. RAID controllers. Yeah, you can have RAID controllers on those. Definitely. We'll talk about RAID later on today, I believe, as well, actually. We'll cover that cablan for you. Great stuff. USB expansion slots. Yeah, if we want more USBs. Okay, that's good. Right, let's shuffle on then. Let's talk about our central processing unit. We know this is the brains of our system. This is what does all the hard work in our computer. Important things we know are processor speed, number of cores, processor cache. Remember our cache? That's the memory that is really close and is really fast. Okay, and the speed that it can access data from the RAM and drives. Those are the important things about our processor. Does all the hard work. We've basically pointed it out. Might take one out. We'll have a chat about taking one out in a bit, actually. So let's have a chat about riser cards. We talked about PCIe. Yeah. Okay, that's great. That's fantastic. If you've got yourself a big box, you've got your big computer system, you've got loads of space. But if you've got a server, well, hold on, we can't mount it vertically. This is our good old example, the HP DL380 G10. It's what's known as a 2U server. Now we're going to use later on, but I'll explain it basically. A U is a certain amount of space in a rack. If you've ever seen a data center, there's big racks of systems and servers that slide in. Okay, a U is a certain measurement in those racks. Now, if you have a skinny server, it's 1U. If you have a big server, it's 2U. If you have something like a switch, a data switch, they can be 1Us as well. Okay, so 2Us is 87 millimeters. Okay, your standard PCIe card is 106 millimeters, so they just don't fit. Now, what we have here is we have a riser card. They can be called daughter cards. Okay, essentially what they are is they are a card that slots into a PCIe slot and then basically puts them horizontally in the server instead of vertically. Here's the rear of a HP. You can see at the back, these are all available slots essentially because they are horizontal and not vertical, and that plugs into a daughter card. Good. Any questions around that? So CPUs, cores. Let's have a look at our cores. On that diagram, we can see basically our CPU performing, and we're looking at the performance of the cores there. So we know with multiple cores, we can do multiple tasks. Okay, it allows you to complete 2 logical processes at a time. Simultaneously, yes, in parallel, if you like to call it that. Okay, and obviously we know that if we're doing multiple things at once, we can do things quicker. But you've got to make sure that the hardware and software have been designed for it. This originally was called hyperthreading. Hyperthreading is where you can take a particular process, break it up into different threads, and each thread you can put to a different processor. And if you can do that, then you can do that entire task all at once instead of doing it one after the other. Difference between cores and logical processors. Logical, physical processors. I'd probably put that down as, Alan. A core itself is a processing system on a single memory chip, on a one processor. Okay, a physical processor, of course, is a separate chip. So you can have two processors. If you have two processors that each have 8 cores, then of course you've got 16 cores in total, but the processors are separate. Does that answer that one for you, Alan? There's a good example there. There's a Xeon Gold, which has 28 cores. So don't think, when you start talking server environments, we're not going, oh, we're restricted to, our i5s, i6s, sorry, i7s, i9s that have multiple cores. As I say, that Xeon Gold basically has 28 cores. They're about £2,600. Stick them into servers, don't break them. But as I said, it's important that you make sure that your software does understand hyperthreading support. Most of it nowadays will definitely do it. The old days, we used to have to keep asking those questions. Keeping it cool. Our processors heat up. They do all the hard work. Okay, they do a lot of the hard work. They get hot. There's a lot of electricity, not a high amount of electricity, but loads of electricity basically going through there. Makes it warm. Okay, we protect these with what's known, this is an air-cooled heat sink. So the air will generally come through it, and the air will blow from essentially the cold end to the hot end. Okay, so that's the idea. It draws cold air in from the outside and blows it through, and then it comes out hot. It's held in with 4 retention screws. I've circled 2 there, the other 2 are at the back. Okay, when you are changing them, please do the retention screws on opposite sides, so on the diagonal, rather than basically putting 2 at the front. What you don't want to do is you don't want to push it down and wiggle it. Okay, you want to avoid that. Avoid the wobble, for want of a better word. We use a beautiful thing called thermal paste. I'm remembering the names now. Thermal paste now, that we squirt on it. And when you're basically putting it down, essentially you're placing, I've got one here actually, you're placing a metal unit. This is a big heat sink, as you can see, with a fan, blows the air through. You're placing this physically onto the processor. And the idea with the thermal paste is you get a very good contact between the two. And a very good contact means you get the heat flowing nicely out of the processor and into the rest of the world. I recommend it's just a little pea you normally put in. Don't smudge it around, simply squirt a little pea on it, place it down, and placing it down, thermal paste, yeah. Placing it down, then basically that squishes it all out nicely. And then if you do the 2 corners and then the other 2 corners in terms of screwing it down, that will then mean it holds it tight. And you get a good thermal contact. So there's a couple of examples of heat sinks. Obviously, it depends on which processor you've got. If you've got a big processor, you buy a big heatsink. If you've got a little processor, well, you don't need so much, so you can get a small heatsink. Marty basically asks there, air-cooled heatsinks works when the environment is 50 degrees C. You are cooling from the air. So if you're blowing hot air into the system, then no, you're not going to have a great deal of effect. Obviously, the cooler the air you're blowing in, the better it's going to be for your processor. Processors like to be run cold. And when we talk about server farms and things like that, we'll talk about hot aisles and cold aisles. Generally, it's a good idea not to put your PC sucking air in from your radiators or your electric heaters in your house, because that's not going to basically do it. And your fan will just work harder and it'll break sooner. Any questions about keeping it cool? You can get liquid cooled ones, both water. I hate the idea of putting anything water near my computer. Ooh, it's just something I don't like. But you can get water cooled ones, okay? Just very similar to your cars, can't you? The old air cooled VW Beetles. No one uses those anymore, do they? Okay, so installation of a CPU. Yes, not all CPUs are the same. Okay, do not force it in. It's either got pins or they've got little pads. Make sure it's the right way around. You can see on those two processors, you can see there's little notches taken out that help you put it in the right way around. Okay, so we slot it in the right way around when everything's fine. It fits really nicely. On the one with pins, you can see there's a pin missing. That prevents you putting it in incorrectly. That's the idea with these. There are multiple types of CPUs. BGA, which stands for ball grid array. So these are little balls. Rather than having pins, they're just little balls at the end, little balls of solder, rather than pins, and they make a good contact. PGA is our pin grid array. That's the prickly one. And they come in different forms. So there's a land grid array, which is LGA, which is surface mounted. Okay, it's good packaging for integrated circuits. And not only that, not only do we either have pins or balls on them, we can have them in different arrays. So you can see there, a pin grid array is everything in line. So you've got nice little lines of trees all in the same direction. Then we can have an SPGA, which is a staggered pin grid array. This allows us to pack more pins into the area that we're dealing with. Okay, and again, more pins is great. And that allows us to build smaller processors. Make sure you're buying the right one for the right slot. And again, your motherboard manufacturer will tell you exactly which one you need. Any questions about installation of a CPU? Great stuff. Well, literally, hold on, there's a couple here. Are BGA directly soldered? No, not directly soldered. They are very simply just little knobbles that basically fit into place. Straight contacts. So rather than having a pin that basically inserts into a hole, you just have a little nub that goes onto another little knob. Much the same as you do with batteries. I'll pop one out for you. I might show you. Might be a bit difficult to show you, but they are not soldered on. Great stuff. Any questions before we kind of whip off for a quick break? We're going to have 5 minutes because we've got a fair bit to cover. Can we do 5 minutes, Russia? Is that cool for you?
Yes, absolutely.
Great. Absolutely amazing, people. Okay, so we're going to have a 5-minute break for a coffee, apple and a banana, and then we'll come back and we'll dive into system batteries. See you in a couple of minutes. Well, welcome back, everyone. I hope you had a quick break there. You managed to get a coffee or an apple in, or just a comfort break. So I know we've got a fair bit to cover today, so I'm cutting the break down a bit. So let's have a little thumbs up. Who can see system batteries? Peter, fastest fingers first. Thank you very much. Matthias, Maximilian, Fintal, Ronald. Wow, we are keen to get back. That's good. Let's see if we can crack through this then. So without further ado, let's talk about system batteries. So the battery is small. Small? I mean, let's have an example of it. It's a similar battery to you put into your watch, into your key fob of your car. It is the same one. I think that's a CR. Oh, I'm going to get that wrong. CR2022 or something like that, isn't it? 32, I think. Okay, so these are exactly the same. You can buy them down the shops. If one goes, yeah, you can replace it like that. But what does it hold in it? It holds essentially our BIOS or UEFI details, which are things such as our date. So it holds the date and the time of the system. Okay, it holds things like the amount of memory that's installed, the drive configuration. So if we lose it and it comes off and it fails, yes, when we reboot, the system might pop up and say, look at the date, it's totally wrong. Okay, at which point you can correct it, or you can pop into Windows and Windows will do it, or if you're on a Mac, you pop into a Mac OS and it will do it for you. Most of the drive configuration stuff will automatically figure it out nowadays. The old-fashioned ones, we used to have to tell the system what disk drives you had, not only as far as what size it was, you had to tell it the manufacturing type, the number of platens it had on it, and that sort of thing. That has all gone away now. We are all very happy plug and play. You plug something in, it understands it, and just goes, thank you very much, you've just stuck some more memory in. I'm getting on with it. Okay, so that's what the battery is for. If you lose it, yeah, we simply replace it. No, I said we talk about BIOS or UEFI. Basic input-output system. It's the legacy type of things. It is very basic. When it boots, this is what your system goes to. Your computer reads this and goes, oh, this is what I've got to do. Okay, boot stands for, well, boot stands for exactly what it is. So the boot order is basically a pre-operating system. So it initializes all the hardware devices, makes sure there's power to all the relevant things, your fans are good, and it will contain things such as your boot order. Okay, this is whether or not it boots off of your SSD drive or whether or not it looks for USB first. In the old days, we used to have fun with people leaving floppy disks in the machines because the boot order on most machines was always set to floppy disk, hard disk. Okay, if someone left a floppy disk in, all of a sudden your system was booting off of the floppy disk, which it couldn't do. So we had loads of people used to phone us up going, oh, it's not working. What have you got in your floppy disks at? Okay, it contains the drives that are installed, the RAM installed, and the date and time. Now we are moving away from BIOS, and now we are using UEFI. Okay, the features are slightly different. BIOS was originally written in assembly, which is ones and zeros, so 11011 type programming. UEFI is written in C, beautiful, lovely language. The user interface for BIOS was console-based, as you see the top window there, all very text-based. Oh, lovely things. UEFI's beautiful graphical interface now. There was limits to BIOS in terms of the maximum drive size that it could access. 2.2 terabytes. Okay, UEFI 9 zettabytes. Whoa, okay. That's why we are moving more towards UEFI. Now, the boot information used to be stored on what is known as a master boot record, an MBR. And that was on the hard disk drive, either on the SSD or the HDD, or the spinny disk one. Okay, and it was written in a particular way. Now, UEFI changed that, and they're using GUID partition table, GPT, lots of different acronyms, aren't they horrible? But basically what that means is it's written in a slightly different way that allows it now to access that 7 zettabytes of data. One of the big changes was security. Secure boot TPM wasn't supported in BIOS, but is supported on UEFI. Now, what that basically means is that UEFI has a chip basically placed on it, which is a TPM chip, and that chip will actually detect and check that disk drive is supposed to be used with this particular system. Essentially, it's a form of encryption key for your PC. So the process is basically that when you power up the system, TPM authenticates it with a cryptographic key and then unlocks your encrypted drive. Windows 11 insists that you have TPM2 or above. This is why a lot of people are crying, because Windows 10 is becoming unsupported. and they have old machines and they're not allowed to use Windows 11. There is a hack for it, but I'm not allowed to tell you there is one because that would be naughty of me. But as I say, I mean, let's be honest, TPM is a security feature. Businesses should definitely have it. Home users, yeah, I definitely recommend you do have it. So here's an example of a BIOS or UEFI. What they do is a post check, which is a pre-operating system test. So it checks the CPU integrity. It checks the BIOS code to make sure the BIOS isn't corrupted. It checks the components like DMA, timer, interrupt controllers. Interrupt controllers are very much used. These are hardware interrupts. And this is what happens if you have a piece of hardware that wants to talk to a system. What it does is it uses an interrupt code. It puts its hands up, and that's an interrupt to the processor that says, oh, I've got something for you. And the processor will go, okay, I need to pay you some attention. So that's an interrupt code. It initializes the memory to make sure it's good, initializes the BIOS, identifies the device for booting, and then provides an interface for any configuration. So you've got an American Megatrends one there. A lot of the time to get into the BIOS or UEFI, you will press a special key. Could be F2, F12, delete to enter the setup. You see there it says press del to run setup. Press F8 for, I can't read that one, BIOS pop-up. Okay, so you have different keys that you press that will put you into something before the operating system is loaded. So this is before it knows it's Windows or Linux on the machine. And this will allow you to make configuration changes. And then once it's done all its tests, it goes, right, let's hand it over to the operating system, loads the operating system, and off you go. Good. Any questions about BIOS and UEFI? Really important you just understand that UEFI is the more modern one. It's the one with TPM and the security system on it. And Canasec's massive disk drives now. I said your BIOS and UEFI are ROM, so they're read-only memories. Okay, they tend to be soldered onto your systems. Good, we're all looking pretty good. Okay, so let's move on to disk drives then. We all love disk drives. They come in different sizes and different speeds and basically different everything, don't they? So the speed of your hard disk drives. So hard disk drive is a spinning disk. It's a set of platters that whirls around. Okay, they tend to run at a revs per minute, so revolutions per minute, just very similar to your car. 5,400 is the old style. 1,400 is really quick. Okay, they have disk caches. They all have disk caches, which is basically a little memory chip that is pretty close to the drive that basically stores the regular stuff you're reading off of it. And that makes the read and the write faster. And they average around 250 megabits per second. Compare that with a solid state drive, an SSD, 7,000 megabits per second. Gosh, I wonder why we're all basically installing SSDs nowadays. Yes, they are much quicker. This is one of the great revolutions that Apple had, was they put SSDs into their laptops. That made them really quick to boot up. You'd literally open a laptop and you go, ping, there you go, I'm ready. Okay, PCs couldn't do that because they're still running off of the hard disk drives because they were cheap, whereas the Macs were expensive. Okay, so it was as simple as that. Nowadays, you bet you'd be lucky to get a laptop that basically has anything other than an SSD. Now, as you can see from there, they come in different sizes. MSAT is the really small one. PCIe SSDs are common in servers. Okay, there's a traditional 2.5-inch SSD. And again, we know we keep talking about it. The reason that the hard disk drives are still in existence is very simply because they are cheap. You can hold a massive data on them really cheaply. So they're great for stuff you do not need to access quickly. So a simple summary on that is SSDs are fast, hard disk drives are slow. Any questions around drives? I can see a couple of people typing some questions in there. See if we got any. Looks like it's gonna be one of these. Crack on with some time. Let's go. Okay, so drive connectors. SATA, which is a suspended IDE cable, was the old fashioned. These are long ribbon cables. So you can see the two different flavors there. So you've got SATA and you've got the IDE connection. Now these tend to basically plug into the back of the systems. The ribbon ones are quite long. They do need power. So your disk drives do need power. So that power connection comes from your power supply unit. If you're basically using a laptop, they tend to be a ribbon format. And that's a laptop connection on the right-hand side. They will only plug into the right sockets. Okay, they have notches in them that make sure you do basically get them. Any questions about disk drives? They are very much plug and play nowadays. Okay, so plugging them in, plugging them out. If you have problems, the chances are it's a faulty cable. You can replace cables quite simply. Great, so what else is on the back of the motherboard? Okay, let's have a quick fastest fingers first then. So, anyone recognize what these are on my motherboard? These are normally connections at the back or the front, depending on which way you look at your system. That is fastest fingers first. USBs, USB 2s are in there. USBs, you could have just called them USBs. They are USB 2s because they're not blue. Blue would indicate USB 3. Good stuff. Next one is in the yellow box. Yellow, I'd like to call that yellow box. USB Ethernet network. Ethernet, yes. Ethernet cables, yes. So it's a network connection. Quite often abbreviated to NIC, network interface connections. Okay, the one in yellow. Let's see who's old. It's only because I am. See how old people are. Mouse, printer, Paolo, not quite right. Mouse and keyboard. A bonus if you can tell me which one's which. These are what's known as PS2 connections. They do still exist. If you ever work in a server room, data center or something like that, a lot of the KVMs that you probably find in there, the KVM, these are ones that run a single keyboard and mouse to multiple computers, and you switch with a button as to which one you're controlling, are run through this particular connection format. So it's a mouse and keyboard. Mouse is the green one. What are these ones in green then? Speaker and headphones, yes. So audio and mic, audio jacks. Yep, that's perfect. Oh, this is replaced with USB now. Why do we have anything else other than USBs? Very good question. Here's an old-fashioned one. Anyone know what that one is? Monitor connection feature. Look at those fastest fingers first. I think goes to Luca. Great stuff. Yes, a VGA connection. And then last but not least, serial port. Marty, it's not a display port. DB9, Alan, thank you very much. These are the old-fashioned serial ports. We used to run printers off of things like this. We used to run everything off of this. This got replaced essentially by USBs, universal serials. This is what we used to have to connect things to. You can tell it's a DB9 or a serial port because it tends to only to have 9 pins in it. A VGA, as in that runs your display, has a lot more. Wow, that was a quick one, Sandra. Thank you very much. DVI is a slightly different runner. I'll show you DVIs later. Great, serial one. So that kind of covers the main things. What else is basically inside our computer system? What's inside the box? Cooling. Keeping the system cool is critical. Okay, if we do not keep it cool, things get hot, we start blowing things up. Okay, it's critical. We need to have the relevant fan, and the fans tend to blow air from the front to the back. Why from the front to the back? Because everything in the front is going to be nice and clean. Where do we face the back of our computer to? Well, against a wall or under the desk or something. So we tend to pull air from the front and blow it out the back. And when we deal with servers, we'll talk about hot aisles and cold aisles. Power supplies. Okay, power supply units come in different form factors. Okay, there tends to be an ATX and an ATA format. Okay, they come with different power ratings from 350 watts just for running a regular machine to your 850 watts that runs things such as your gaming computers. Why do gaming computers need a bigger power? Because they run that GPU and they run extra fans to try and keep things cool. Okay, so they need the extra power rating in there. So they tend to have a particular rating. So they are rated to either 110 volts or 240. In the old-fashioned day, they never used to be auto switching. We used to have to manually push a switch across. If we moved a computer from UK into Europe, we'd have to push a switch across so the power supply unit didn't go pop on us. Okay, so they run different power supplies. Nowadays, they're all auto switching. Okay, but go careful and bear that in mind if you do happen to be moving devices around. Other things on the system, things such as GPUs, our graphical processing unit. Yes, we know these are important. These are physical cards. They tend to be plugged into the PCI 16 slots. Okay, it has a processor inside it. Lots of them have their own cooling systems. Big fans, you see the example there. Massive fans on the GPU to try and keep the GPU cool. Because a lot of the time, if you're playing games and you're doing a lot of heavy graphical stuff, your GPU is working harder than your processor. Now, when you take apart the box and you're literally looking through one of these things, a motherboard, and trying to plug things in, they have other connectors. Now, there's one very common thing, and I've said it before, you will notice about all these connectors. And that is they are all different. Our CPU power cable will not plug into the motherboard power connection because it's totally different. It won't plug into the CPU fan because it's totally different. I can't plug my CPU fan into my front LED because they're different. Okay, there are different colors for front USBs, different notches knocked out. You notice the front LED has got second row port number 3 is blocked out, and that prevents you plugging it into your front media section. So they are all different. So don't be too scared. And as I said at the start, when you're pushing them in, if it doesn't feel like it's going in, double check that you're plugging it into the right location. But you should always be able to plug them into the relevant places. Any questions about other connectors on the systems? Good stuff. Okay. Thanks. I hope that's good. I haven't just blown you all away. Now we're going to drop into a breakout room. I'm not sure if we're having a breakout room or if we're just going to have a general chat. It's a general chat, wasn't it, Rasha?
Yes, exactly.
Perfect. That's good. Okay, so what I want you to do is to look at. I've done a lot of talking, so I'm now going to get you guys to do a lot of the stuff. So we have this website. If we can go to this website. And I want you to have a look. I basically poked it into the live chat window. I'm going to ask you to all basically go away and build, just select the items to build a PC. So what you'll be presented with is this system builder. Now this helps you build your particular system. Now remember all the stuff I've been talking about. I'm not going to set a price limit. I'm not going to set a minimum and maximum. build what you fancy. Don't go crazy, or you can go crazy. No one's going to actually, don't click purchase, or I'm going to get into a lot of trouble because we're not going to afford this. Okay, so add components. Think about what you're building. Okay, and bear in mind there's compatibility issues. You've got about 10 minutes we're going to have on this. So that's 6:30, so 6:40. I'm here for chat, so if you want to have some conversations or you want to basically get things, build it, and then happily you can poke it into the live chat or share some information about what you've selected. So I'll show you an example. So I can add a processor, hit add component. It's going to give me a massive list of processors. Okay, but I've got to bear in mind that if I'm picking an Intel processor for 500 quid, yeah, for £500, then I then need to add a motherboard that supports an Intel processor. So I can come here and pick chipset, and I can say it needs to support an Intel processor of the type that I picked. And don't worry, because this is very helpful. Because if I get it wrong, it tells me. It says there's a compatibility warning. CPU does not come with a stock ruler. Possibly not that one. Okay, so it should tell me if there's an issue. Now you can feel free to open your mic and have a chat with us if you want, or you can basically put it into live chat. As I say, I'm here for any questions if you have. Oh, we've got the first one up there. Ragib has basically poked a good example up there. With some good tips. I like number 4 particularly. Number 4, GPU and case. Physical size. Make sure the GPU will actually fit inside your case. Yes, if you buy a small case, bear in mind, if you buy a big GPU, it's not going to fit in. If you want to do a lot of fast graphics, you are after a PCI 16. PCI 16s tend to be longer slots. So make sure your motherboard has a PCI 16 slot. Edward, why did you pick a AMD Ryzen over an Intel? It's not a right or wrong answer. It's a open question. Last period of time, Ryzen overtook Intel, in my opinion. Yes, and if you look at the processing, if you compare the two processors, it's very interesting to see which one does which type of thing better than the other. I think Intel basically claims it does. I know Ryzen, I think, manages a lot of the graphical calculations and things like that a lot better and will handle that. And I think Intel still go, oh, we crunch numbers better. But you can look at the specs on them, can't you? And you can have a look. But yeah, definitely. I've got I built a game machine for my son. And literally went the Ryzen all the way down. I can also see you've got bags of money. 3 grand on a graphics card. Whoa. Lovely. Lovely stuff. Let's have a look at what Marty built. There's an Intel Core i9 there. We're allowed to dream in this one, aren't we? Marty, did you randomly pick anything, or did you pick anything because you know it's good and you love it? So you've got a gigabit motherboard, which is the Z790. These are specific gaming motherboards, aren't they? Which are great systems for gaming stuff. Cheaper graphics card. Lots of good stars on it though. Great for gaming, yeah. I can't say I blame you on those ones. You can see the power supply there. Sometimes power supplies are great. If you don't pick a big enough power supply, your system will drain it and it'll pop. It won't be great. You can see here there's a gold power supply, 1000-watt, fully modular eco model, okay, with some beautiful fans in it. So 1000 watts of power for supplying that. And I bet a lot of that is basically drawn by your graphics gaming card. Not to mention the 10 fans you probably have to have in the chassis unit. Everyone managing to get a form of PC, a form built? Alan's another Ryzen favour there. Okay. I know definitely when we're one of the next task that we set you is basically going to be to build a PC for a specific task. So this is good fun, and we're dropping in and we're having a play and we're picking different items, which is fantastic. And we're dreaming. I can see a lot of them are dreams and are beautiful. One of the tasks that we're basically going to give you is we will ask you to build a PC for a particular requirement. So we will set you a task. We will go, you've got X hundreds of pounds. So we're not putting a massive graphics card in for 3 grand. X hundreds of pounds or euros. I can't remember which flavor we did it in this time. And you will be asked to pick items based on what that person needs. So last week we spoke about the requirements. You know, if you're doing a lot of heavy graphics work, yes, you need a graphics card. But how important is the memory to you? How important is the processor speed to you? Which ones are your priorities? So you've got to take the money you've got and you've got to prioritize that money to build something that is suitable for that particular user. See what Matthias has built there. Another AMD Ryzen in there, Cool Master. Yeah, cooling systems is really important. So we need to make sure we are cooling things down. A lot of you are going for 64 gigs of RAM. Yeah, fantastic, isn't it? 2 chips. Matthias, could you expand on that? Could you increase the amount of memory in that system? That's a question for you, Matthias, isn't it? If you needed to later on in a year's time. If you fancied an upgrade on your DDRs. Misclick. Thank you. It's all right. It's fair enough. Oh, you've got 2 loads. You've got a Corsair in, haven't you? 232s. So obviously we've got to check in there that we have 4 memory slots. Chances are on that motherboard we probably do. So we can have a look on that motherboard. And we should be able to see how many memory slots it's got in it. Socket, so memory supported 4. So we've got a quad channel, maximum up to a 128. So we're pretty much pimped out on that one, aren't we? Great stuff. Okay, so that was good. We're kind of ticking over to 640. Anyone got any questions about that particular task? Anyone struggle with it? I mean, you seem to do really well. I love some of the models that you picked in there. Obviously, we've all got endlessly deep pockets. When we set you a task, we will give you a finite amount of money and we won't let you just hemorrhage the cash. I can see a couple of you typing there. So any questions? Anyone fancy a chat about what they picked? Can we order now? Very deep pockets. Luca, no. I'm not sharing my credit cards with anyone. Okay, that's good. Okay, so if we can all come back to the room, for want of a better word, we've got a couple of bits and pieces to cover, which is going to be some fun stuff. So, safety. Oh, who mentioned safety? Yes, we have to be careful. We are basically putting 5 amps. More than 5 amps can happily kill you. Okay, so when you're running a 850-watt power supply unit, you're probably going to be looking at 3.5 amps, the main point there. Yes, you could very happily kill yourself by playing around in the system. Unplug it, pull the cable out of the back, and then play inside it. Okay, it's important for your safety as well as for the safety of the electronics in there. Okay, I have seen people use earthing cables, which they normally tie around their wrists, and they plug onto something metallic in their room, a desk or something like that. For my sins, I've never used one. Touch wood, I've never blown a chip. That's not to say it doesn't happen. The reason they do sell is because it does happen. Okay, servers are heavy. Some systems are really heavy. Some systems you will need 2 people to lift in and out of racks. Please bear in mind it's your health and your safety. Please be aware of all these issues you could well encounter. So what's the server then? We talked about PCs a lot. We do a lot on PCs. Great stuff. We do a lot of that. So what is a server? I like to simplify it, and people will shoot me for this. It's just a big PC. It's as simple as that. Yeah, they look complicated, don't they? So there's a front panel, and you can see different disk drives in the front, and you can see different notations in there. So we can see a lot of quick removal access panels, other bits and pieces in there. Yes, there's an awful. I'm not going through them in a list, okay, straight away. But you can see the front and the back of the server there. Do they have anything that we don't have in a PC? They have more of the same thing. Network cards there. You can see 16, 13, 12, etc. They're all network cards. Ignore 13 a little bit because that's a dedicated ILO management port. We'll talk about those things some other time. Double power supply units. Yes. So we have double power supply units. Physically, what goes inside a server? Well, exactly the same sort of thing that goes inside our PCs. Okay, so there's nothing scary and different in there. Wow, and to show you that, this is one I prepared earlier. Right? This is a HP server. It's a 2U server. You should not pick it up on your own. He says confidently picking it up on his own. Oh, sorry, that was. Okay, so that's our server. Now, what does it look like? We've got a case on top. We've got a button we can press that allows us then to remove the lid. Okay, in here we are seeing exactly the same as we have in our PC. We have our RAM chips. Okay, which we can pop out just like any other RAM chip. Okay, we have processors. We've got one processor in this one with a cooling fan. There is space for a second one that I could install or not install whenever I fancy. First processor talks to this memory. Second processor talks to this lot of memory. Notice it's empty because I haven't got a processor. Sounds good? We mentioned the two power supply units. A lot of stuff on servers tends to be plug and play. You can hot plug and play systems. Okay, I'm not sure if I'll be able to swing this round enough for you to see. But at the back there, oh, my power, nearly got it, nearly got it. If I drop this, it will land on my foot. Okay, two power supply units. Okay, these are hot plug and play. If this system is running in a rack and one of these power supply units fails, the system will carry on working, but at a lower power supply. So it will still work. If I wanted to change one, I can simply pull it out. I've got another one in my back pocket, of course, because I always carry two in a rack. And I can slot it in. And I can do that while the server is live to save bringing the server down. So that's what we term as hot plug and play. And you get that on servers. We can do that with things such as our cooling fans. These are designed to take air from the front and very simply blow it towards the back across the system. Okay, these tend to be hot plug and play, and there's normally a catch on these, which allows us to slot it out and slot it back in. As are the disk drives. Disk drives. I'm never going to show you the disk drives. Or am I? Let me spin it around to see if I can show you the disk drives. Disk drives tend to be hot plug and play because a lot of disk drives do fail on the systems. And this is a common thing that you will be doing if you work in a network operations center. Okay, if I get the right one, they are normally a catch, which pops out a lever, which allows you to pull out a disk drive. Okay, we can then replace that disk drive. If we have a RAID failure, we push it back in, push the catch down, the system will go, thank you very much for plugging it in, and it will start writing to that disk. Any questions? A server is a big PC, multiple items in here, multiple memories, multiple fan systems, because we don't want one fan system, because if it fails, the whole thing goes up in smoke. So we put 4 in here. Bigger servers have bigger things in it. Good stuff. Right. Any questions around that? I'm going to switch back my videos. Back to me. Here we go. Hard drives. Alan actually asked questions. Are hard drives normally one, or are those special types? Hard disk drives. The hard disk drives you put into a server can be any type you like, as long as they're compatible with it. So I pulled out there, that was a 5 1/4 inch hard disk drive, a spinny disk drive. there is no reason I couldn't get a chassis adaptation and simply put an SSD in that location. Okay, the connections at the back are exactly the same. And you can get conversion chassis for the old flavors, or you can get these. You notice on the slide deck, all these ones at the front, these are all SSDs in that server. They're all the little 2.5-inch SSDs in a chassis rack. Little red button you push, lever pops out, pull it out, slide it back in. Does that answer that question for you, Alan? Now, to add to that, have I got one? I'm sure I've got one somewhere. Yes, there it is. To add to that, because servers are really important, they tend to have the ones at the front, or basically that are mounted, the disk drives, tend to run the applications. They tend to run all the fun. A lot of the times in servers, you'll find essentially one of these, which again, it's an SSD drive, but it's the sort of thing you're probably more familiar taking out of a laptop, and they will put the operating system on that, and that will actually live at the back in the chassis. Okay, and then the rest runs off of the RAID stuff. So it's normally a hard disk drive. No, nowadays, Alan basically asked there, hold on, I'll come back to you, Sebastian, give me a second here. So part of the benefits with servers is that you can run multiple things. They don't all have to be the same. You see there, I've got about 16 disk drives. They can be totally different, those disk drives. They don't have to be all the same. They can be totally different. Some of them can be hard disk drives. Some of them can be SSDs. They can be different capacities, different sizes, different speeds. The system will cope with it. Modern day servers are normally SSDs. The reason I would put a HDD, hard disk drive in it, is because they're cheap. So if I had an archive storage server that I was never going to touch and was only ever going to use if some auditor came around in 10 years' time and said, oh, what was on this system, then potentially I would just spend the money on something else and buy loads of cheap hard disk drives and just very simply stack it up with that and write the data to it and then leave it. There's another question there. Sorry, let me come back to Sebastian. The RAM can also be changed. No, if you want to change RAM, you've got to turn the system off. There are some things that are hot plug and play and some things that aren't. Read the manufacturers. If you're in doubt in a data center, refer to the manual or to a more experienced colleague. If you're on your own, shut it down properly and then do it. There are two, one in the front for the OS. Yes, I mean, you can put, Alan's basically said there, so are there two, one in the front for the OS? The example here that we've got, those two little ones at the front, which I think you're pointing out are number 4 on the system. Those two can be for the operating system, yes. And it's good to separate those from the stuff that are doing the rest. And indeed, they may be on what is a different RAID controller. So a separate controller card. So if one controller card goes down, the other one doesn't get affected. And we'll talk about controller cards in a minute. The modern ones use SSDs, 3D NAND technology, and the DDR chips. Modern servers basically use SSDs. Okay. That's generally what it wants. DDR chips, yes, 3D NAND. You can add those in. I mean, the device I showed you basically does have, the server does have its own separate little SSD one that comes in its own individual slot and is about that big and plugs into the back of the, plugs into the system, so it's screwed in. Servers are great fun to play with. Don't be scared of them. They are just like PCs, but as I said, they have loads of different things in, and most of the stuff in here is to keep the system running. 2 power supply units instead of 1, multiple fans instead of 1, multiple processors, multiple memory. Basically done to make it more stable, more powerful. Any questions about servers before I jump into RAID, which is RAID arrays? Okay, so let's have a quick spin through RAID. We've got about 5 minutes. Whoa, we're going to manage to cut this fine, but we're going to get there. RAID. Okay, so redundant array of independent disks. Yes, they're independent disks. There are some very simple concepts here. The two concepts you need to be familiar with. Two concepts you need to be familiar with are mirror and stripe. A mirror is exactly what it says on the tin there. So mirror is two disks copying each other. So A is copied to B, sorry, A1 is copied to A1 on the other disk, a total mirror. So what gets written to one drive gets written to the other drive at exactly the same time. The benefit of that is that if one system falls over, well, you've got exact copies, so it just runs off that. That is a mirror. Striping is where you write across the disks. So you've got two disks and you'll write one set of data to one disk and another set of data to the other disk, essentially striping across it. The benefit of that is you're writing twice as fast because you're writing to two disks rather than one disk. Thumbs up if you all understand those two concepts. If you understand those two concepts, then we will slightly throw a little bit more complicated stuff in it, but it will not be horrible. It will be beautiful. Good. Cablan's in there, Alim, Maximilian, Edward. Put a hand. Okay, you've got to basically mention if you don't understand that concept. I can see you're doing really well. Thank you, people. Before I move on, I want to make sure that you all understand that. Sebastian, what's the question? Any particular things you're worried about? Mirror is what it says, as in it's a total copy. Stripe is written across, so it's written to both. Thank you very much. We have to avoid RAID 0. We're going to RAID 0. Okay. As Cablan's mentioned it, we will basically pop in. Okay, so RAID 0 is that simple striping I have just said. So RAID 0, you are writing across all the disks at the same time. So that means you increase the speed because it is written between two or more disks. Okay, RAID 1 is a mirrored disk. So two or more drives are written to identically. So you can have two or more. So I can have my left-hand part of my RAID 1 can be 6 drives. My right-hand side will be another 6 drives. Okay, they can get stacked up, but always think of them sort of as a mirror, a total mirror. The benefit of that is that if you do have one of them fail, then the system carries on. So that's a toss-up between, do you want speed with RAID 0, which is striped, or do you want redundancy with RAID 1, which will handle a failure? Then just to add to that, we go, well, let's have RAID 5. What's RAID 5? So RAID 5 is striped disks with distributed parity. Now, remember we talked about ECC memory with the parity check? Pretty similar to that. So what we do with RAID 5 is we write stripes across 3, 4, 5 disks. The additional disk, as in the last disk in that set, is written with parity. It's not quite the last disk, but that's why I'm going to look at it. It's written with parity. That means we are writing that data really fast across a striped set. But if one system falls over, we've got the parity written on all the other disks to allow us to rebuild that disk or get that data without failing over. So it gives us redundancy. So it's 2 or more drives, identical data written to them. A single drive can fail with no data loss. But your total size is reduced by essentially the last disk on the end. So if I've got 5 disks in my RAID 5 array, essentially I've got the size of 4 disks, and then one area of that is used for basically the parity. Does that make sense to everyone? Thumbs up if that makes sense. Most disk drives you will see in servers and places like that tend to be RAID 5 because it is the most efficient manner of spending your money. Good. Okay, RAID 6 is double parity, so it's a bit of an expansion. Okay, imagine RAID 5, you've got one disk essentially is the parity, 4 disks are working, one disk is a parity. RAID 6, oh, hold on, we've got another disk. So we've got 2 parity disks. So we're writing parity twice as much, which means we can fail 2 drives and our system will still work. Good stuff. And then last but not least, it's not last but not least, we cover another couple, is JBOD, just a bunch of disks. Right, this is where your RAID controller just says, I'm not going to do anything special with these. It is just a bunch of disks. So your operating system will see it, your applications will see it as, instead of seeing 5 individual disk drives, it will just see one massive disk drive. And that's all your system will care about. Just a bunch of disks. No parity, no speed increase, nothing on there. Just a bunch of disks. Cablan's obviously done some research before, knows what he's talking about. What about RAID 10? Yes. There are other types of RAID out there. RAID 3 is a striped set with dedicated parities. Don't worry about that. You might not get asked any questions about that. RAID 10 is our 1+0. So this is a striped mirror. Okay, so essentially what we have is a stack of disks that we're writing striping to really fast. Thank you very much for writing striping to. And then we take another bunch of disks and we simply copy exactly what is being written to that. So that is a striped mirror. You can lose loads of disk drives in a RAID 10. Okay, I think you can lose up to about 4 or more drives before it starts becoming a bit of an issue. Okay, the problem with it, the big problem with the striped mirror is that you're using loads of disk drives. Where I used to have 5 disk drives, I'm now using 10 disk drives. Double the amount of disk drives, double the cost. Who wants to pay double the cost? Just go RAID 5. We get faster with parity. Everyone's happy. Does that answer that one, Cablan? That's why you don't see RAID 10 very much, unless you've got mission critical systems. Good stuff. Well, basically, hang on, we are 3 minutes over. How dare I? Sorry about that, people. We are pretty good. There's some RAID numbers here, which are in there. We don't have to go through these, but we're basically, we'll help you through on some of these. Like I said, a striped data has a full 768 megabytes. In this example, we're using 6 drives of 128. Mirror were half because we are only using half of those disk drives for writing data and the other half we're basically copying it. RAID 5, we lose the last disk space. So we're down to 640 megs. And then 10, we are down to our 384. Again, we are halved. Good. Has anyone got any questions about RAID? CompTIA covers it briefly when they do the exam to this level, and that's why we kind of cover it to this level. Important thing you need to know the difference between is a mirror and a stripe and RAID 5. Those are really going to be the ones you need to worry about. All good, Alan. That's cracking. Okay, so as a bit of a conclusion, just rounding off the edges here, we've covered what goes into our computer. We've shown you the motherboards. We've shown you the toys that go inside it. We've shown you the difference between a desktop PC, laptop PC, and your server system. So your big server, just a big PC essentially. Okay, we've looked at motherboard architecture and the importance of picking the processor and the memory that fits on your motherboard. So you're buying your motherboard and then sticking things onto it. And we talked about upgrades. You buy your motherboard to allow you to upgrade further from what you want, because you don't want to buy a PC motherboard that's going to be good for 2 years. You want to buy a motherboard that's going to be good for 5 years, because you know in 2 years' time, that 64 megs of RAM you've got in there isn't going to be enough. So you're going to want 128. So you want a motherboard that will support potentially double what you're actually putting in it. That's if you want to look at upgrading prices. That kind of brings us to the end. Thank you very much for letting me run over by a couple of minutes. Any questions were always available for